Good morning, class. What we're going to do today is we're going to take some notes on graphing log functions. This handout is on the back of this one. So one side looks like this, evaluating logs, and the other side looks like that. Okay, on the side that shows evaluating logs, I want you to write your name, class period, and date up at the top. That way it's in the central location. Everyone has it on the same place on each of your papers, and I don't have to struggle looking for the name on your notes, okay? So let's turn to the back. And on the back, we're going to talk about graphing log functions. Excuse me. Our objective for today, so I'm going to zoom in so that you guys can see this. So our objective is to determine characteristics of the parent log function and how to use transformations to graph. So we're determining the characteristics of the parent log function and how to use transformations to graph. If you look at the first page, this would be like our first page says y equals to log base 2 of x is the inverse of y equals 2 to the power of x, which we learned a lot about that last week when we learned how to rewrite the log function into the exponential and the exponential into the log. We know that these are equivalent to each other in the way that they are, I just want to say equivalent, that they are related to each other in the way that they are inverses of each other. All of the x and y values of y equals 2 to the power of x are switched, and when they are switched, you actually end up getting the x and y values of the log function. So I want you to write reflected over the line y equals to x. We also spent some time last week solving for the inverse function. So I gave you a function and you ended up finding the inverse going in both directions, but for the most part we stuck from log to exponential. Okay, let's go ahead and go to the parent function and let's talk about transformations. Transformations of the parent function are pretty cool, okay, very easy. So if you look here, you're going to have your function, whatever the b is, that would be your parent function. So if it's log base 3 of x, then that would be your parent function, and of course we're going to add some transformations to it. The parent function always passes through the point 1, 0 and b1. So whatever our base is going to pass through that base point and 1 and 0. The vertical asymptote is dependent on your h value, and in this case h is equal to 0. And you know what, as a matter of fact, let's go ahead and write down what a, b, c, h, and k are. In this case, a would be the number in front of the log, which is just 1. b, in this case, is a general b. The b would change. C is the number in front of the x, so it's just an imaginary 1. H would be the number after the x inside the parentheses, which is just nothing, 0. And then k would be plus k or minus k, which in this case is 0. So our vertical asymptote for this parent function would be h equals to 0. Sorry, I shouldn't put h equals to 0. I should put x equals to 0. So that means that there's an imaginary line here on the line x equals to 0. That's your vertical asymptote. Okay, our domain depends on the vertical asymptote. In this case, the vertical asymptote is 0, so my graph is going from 0 and above. So my domain is from 0 to infinity, or you could write it as x greater than 0. Okay, and then the range is going forever up and forever down. So we can tell the forever down. The forever up is a little bit harder to see, but it's going forever to the right and then forever increasing slightly. So the range is all real numbers, which another way of writing that is negative infinity to positive infinity. Okay, here's our general form. A, which is the number in front of the log, reflects over the x-axis if A is less than 0. You would multiply all of the y values by A. If you have x minus h, it would translate to the right. If you have x plus h, it would translate to the left. Remember that anytime it's inside the parentheses, it's the opposite of what you see. Okay, the letter H is also important because it determines your vertical asymptote. The letter C in front of the x on the outside of the parentheses says that if it's less than 0, it reflects over the y-axis, and you're going to divide all of the x values by C. And then finally, the one that you guys are probably the most comfortable with is K. If K is positive, then you're going to translate up. If K is negative, you're going to translate down. Okay, using all of this information given in this table, we're going to start to apply what we learned. So go ahead and turn to example 1. The first example I'm going to do just by myself, okay? You're going to follow along. That will be your example to follow. And then example 2, you're going to do it with your partner. And then example 3, you're going to do it on your own. Okay, so let's look at this. Number 1, what is the value of A? A is -2. B is 2. H is the opposite of what we see, so it's going to be a -2. And K is -3. The only number that I didn't fill out, which is different and new for you guys, is the letter C. The letter C would be that number in front of the X, which in this case is nothing, so it's just an imaginary 1. Asymptote. The asymptote for the vertical asymptote for this function depends on H. So whatever H is, that's going to be our asymptote. And in this case, H is -2. So that means that our vertical asymptote is X equals to -2. The next thing we're going to do is we're going to take all of this information and we're going to plot it into our table. So I know that H is equal to -2, A is equal to -2, and K is equal to -3. Okay, if you are in first, second, or 8th period, this table might be a little bit confusing for you, but if it is, you can skip it and go to just graphing it into your calculator. If you want to get the extra challenge and try to follow along, you can. 3rd and 7th period should be able to do this, okay? So we know that the points on our graph are always 1 and 0 and are always B and 1. In this case, we know B is 2. So these are our starting points on our parent graph. Okay, if we were looking at our parent graph, we would start with these 2 points. Okay, it says add -2 to our x value. So I know that this is my x and this is my y. So the x value is the one that's going to change. My y value is going to stay the same. My x value is going to be the one to change. My y value is going to stay the same. Okay, on the next part it says multiply y by a. So this is my x and y. So I know whatever x is, you know, in this previous one, but then we're going to change the y. Whatever x is, and then we're going to multiply y by -2, so that's going to change that function, that coordinate. We're going to rewrite the same thing, x and y, and it says add -3 to the y value. So whatever x is going to stay the same, but my y value is going to change. Whatever x is going to be, it's going to stay the same, and then y is going to change. Okay, so that's just setting up the equations. So now let's do the math. if you add -2 to x, 1 minus 2 would be a -1. If I add -2 to 0, so this is going to stay -1, -1 for the remainder. If I add -2 to 0, so if I multiply 0 times a -2, I'm still going to get 0. And then if I add -3 to 0, I'm going to get -3. So that is our first ordered pair, -1, -3. And you look at the next line. Add -2 to x. Well, 2 minus 2 is 0. So in the next line, it's going to be 0, and the next line, it's going to be 0. So the changes are only happening to your y. So I'm going to multiply y by -2. 1 times -2 is -2. I take my y values again, and I multiply times a -3. -2 times -3 is a positive, I said multiply. I add, okay, so add -2 minus 3 would actually give you to -5. Okay, so we're going to plot 0, -5, which is here. And then the example gives you another point, okay? Do I know what my vertical asymptote is? Yes, I know that it's at x equals to -2. So at x equals to -2, I'm going to draw a dashed line going all the way down where x is equal to -2 to represent my vertical asymptote. So I know that my graph cannot go past this line. And I know since my graph is negative, it's going to be pointing down. So my function is coming down. You're going to connect the dots with a slight curve, and then it continues to go to the right. That's what your first graph should look like. Now, if we look at the transformations, this is where we apply what we've learned. Adding -2 to the x power tells you to move to the left 2, right, when h is negative. When I multiply y by a, that means I'm going to reflect over the x-axis, and I'm going to stretch by 2. If I'm adding -3 to the y value, then that means I'm moving down 3 units. Take a moment to think about this function. Okay, oh, and I forgot domain and range. Domain would be dependent on your vertical asymptote. So it's going to be all the x values that are greater than -2. Or you could write it -2 to positive infinity. Okay, the range is always going to be all real numbers. Okay, after looking at example 1, we're going to go ahead and move on to example 2. Example 2 is a very good example, okay? The only difference in this example is that it has a 2 in front of the x, but it's inside of the parentheses. So I actually need to factor out the 2 and bring it to the outside. Okay, so I'm going to put factor out the c. So my new function is going to be log base 3 of 2 on the outside times x, right? Because 2 times x gives you 2x. And 2 times what gives me -2? Of course, it would be a -1. So starting with this equation, after we factored out the 2, go ahead and complete this with your partner. Pause the video, and then I'm going to give you the answer to this. Let's check how you did. The a value should be 1, the base is 3, your c is 2, your h value is a +1, and k is 3. We know that our vertical asymptote comes from h, and in this case is 1. You're going to fill in the values. C is equal to 2, h is equal to 1, and k is equal to 3. We always start with 1, 0, and in this case our base is 3, 1. I went ahead and put in the blanks, and let's do that part now. I will continue the rest of this on a different video.